get this chapter finished. Okay, so the natriuretic peptides they're going to come from the heart. Antidiuretic hormone. Not sure if you guys remember that one from the endocrine chapter, but that's in the posterior pituitary. This is going to kick in when the body is dehydrated. So what it wants to do is make sure that as little water as possible will leave the body. And one of the things that that'll definitely act on is the collecting duct. The parathyroid hormone. This is the hormone that is affected by calcium levels in the blood, because calcium is so important in muscle function and nerve function. So what that one wants to do is make sure that if there's not enough calcium in the blood, that one doesn't leave the body by way of urine, that we actually get to return it. So a lot of things are happening during this second stage of urine formation, leading up to the area that's going to be the collecting duct. At this point, we're now entering a third stage. So at this point, we want to make sure that we conserve as much water as possible. Because like I said, if we have 150 to 80 liters passing through of the fluid, we need to make sure that we don't get rid of more than about 1 to 2 liters. So, their job, let's make sure we only eliminate waste. All right, for example, the nitrogenous waste or the urea. So, if we look at the water, make sure we don't have excessive water loss, because that's bad for the body overall. So the collecting duct, it begins a small portion at the cortex, but not a lot. Now, as we begin to move or pass down through that collecting duct, we want to make sure water returns to the body and the urine gets concentrated. So, as it moves through the collecting duct, that osmolarity in the medulla increases. Okay? Remember, 600, 900, 1200, these salts and everything? So, the collecting duct becomes very permeable to water. It's going to allow lots of water to move out of this collecting duct and return to the body. So, hopefully, by the time it gets to the end of that collecting duct, our urine is very concentrated. We have taken that 100%, that if we think on the 100 liters, by the time you get down, it's just a few milliliters that are getting formed. So, we're dependent on a process that is going to be termed the counter current multiplier. Well, let's think about the term for a second. When you hear the term current, hopefully you think about water movement, fluid movement, so to speak. This is what is happening in both the tubular system as well as blood vessels. Okay? Now, counter. If something is counter to the other one, which direction are you thinking about movement? Opposite. Yeah, I knew what you meant. Okay? Opposite direction. So if tubular fluid is moving in one direction, hopefully blood flow is moving in the other. okay? Counter current. So what we find is as the loop, okay, passes and the saltiness of the medulla increases, as we get to the collecting duct, it's in the same situation as it moves down into the medulla, because the medulla is this portion, and every single one of those collecting ducts are making their way to one of these peaks. Is that correct? The papillas? Does everybody remember that? So, once again, that collecting duct is moving down and it's getting more salty. So, hopefully, based on the structure of fluid moving, okay, because it's going to pass down this direction, relationship to blood vessels is this way, and then as we go up, blood movement this way. So we end up with this really cool cycle that begins to happen. That's called the counter current multiplier. Basically what's going to happen, we'll get a continuous recapture of salts as we go through that loop. That goes to the medullary tissue, making it more salty, which means we're going to get more water moved. So water moved, salts moved, we're keeping this osmolarity, okay, because we're coming down, increasing the salts, going up, we got more water. We're affecting movement of both the salts and the water. But at the same time, the blood vessels that will be here can move materials back into the tubular fluid. Okay, so we end up getting this really cool structure where we get more salt added to the tissues. The higher the osmolarity of the extracellular fluid, the more water that will get to leave. The water that leaves, the saltier it remains in the tube, so that the salt moves back out. So the saltier the fluid gets, once again, the more salt that will get pumped out. And then as we continue into the collecting duct, hopefully we're going to continue the process so that we're going to get more movement through that collecting duct of the water out. So by the time we get to the CD, we want to make sure that water goes back to the bloodstream. At this point, those nephrons that dipped into the medulla, okay, so if this was my cortex, this was my medulla. The cortical nephrons, which were up here like this and did this number, okay, to meet the collecting duct. All right, because remember, several nephrons get to meet one collecting duct. Do you guys remember how this one had all the blood vessels up here in this direction? But then the ones that dipped way down like this and then met, well, that's kind of too high, then met the collecting duct. Do you remember how the blood vessels kind of looked like this? On their structure. This was our vasa recta, where blood flow is doing this number and fluid is doing this number. They're running counter to each other so that stuff can move out, make it to the bloodstream, stuff from the bloodstream can come back to the tubular fluid. Does that make sense? The counter current system. So, like I just said, as it flows down, more salty. As it goes back up, salts are given out, get more water. so that we get this situation right here. Actually, it's really easy to look at, okay? Basically what it's telling us, in the portion of the glomerulus, the blood flow, the glomerulus at this point of the PCT, they're letting us know that at this point, nutrients have been removed. Why? What nutrient?
Glucose.
Glucose. Salts, yeah. The salts are going to help contribute to the salinity. As I begin to move through my loop, what I have left is water, salts. Is everybody following me? So, if my blood flow is this direction, tubular fluid this direction, based on how salty, that's going to allow water, keep salts. Salts are going to come in. Water's going to hopefully make it to the collecting duct back into the body. And in this countercurrent system, I get more salts back to my body, and the waste stay in the system. So that hopefully, as I go through over here to this point, I'm collecting my nitrogenous waste.
So the collecting duct is where that last percentage of water comes out of?
Yes. The last tiny amount of water left makes its way to the collecting duct. Now, because at this point, we can still be dependent on hormones, not all the time, only when the body is dehydrated. Under normal conditions, hopefully the collecting duct continues its process. We continue to get a little bit of water moved, and by the time we're done, we have created urine. But we can have a very diluted urine or concentrated. Okay, I'm sure you've all seen and had it and seen pictures and so forth. Yes, you can hyperhydrate. All right. Yes, you can hyperhydrate to a point of death. Okay, we're not going to go into that. But it can happen. Okay, you can dehydrate to the point of death. Okay, when hydrated properly, we don't need any hormones. We're going to have movement. We don't need the ADH. We don't need to conserve more water. Things are good. We're going to continue to flow through that collecting duct, produce a urine that should be the normal color when properly hydrated. At a time when dehydration has occurred, for example, maybe that time of trauma, maybe it's a situation where you exercise too much, whatever the case might be, ADH gets secreted. When ADH, antidiuretic hormone, gets secreted, it's going to act on the collecting duct. This is the point that ADH plays a role. So it'll act on the collecting duct. More water stays in the body, and urine gets extremely concentrated. Can be to the point where very little is actually produced at all. So this is a summary of what happens with where we start with the filtrate being made and movement of materials through this system. So you can see that a lot of what gets returned back to the body at the area of the PCT, a lot of it is materials they consider nutrients. We don't need proteins